Tease.
Sounds
Okay.
good.
Yeah. Okay. I think it's time to start. So welcome everyone. My name is Cécile Pereire. I'm from CMU and I will be the chair for this session. Our topic is requirements and more, but actually the title should be more and requirements because we only have 2 papers on requirements. We have another 2 papers on software quality and we have 1 paper on scaling agile. So we're going to have a fairly diverse set of topics and papers and presentations. You probably all know about the rules, but I'm going to remind them to you anyway. So we are going to have 5 short presentations, each being 5 minutes long, with no questions in between. And we'll keep all our questions for a discussion, an interactive discussion at the end of all the presentations. So I'm going to ask you to try to contribute, all of us try to contribute to question to all the presenters so we can have an interesting discussion. It's going to be challenging because of the fact that we have 3 topics versus 1. So I will ask you to prefix your question with the name of the presenter. So for instance, if I want to ask a question to Sophia, I will put in the chat at Sophia and will ask my question, and I will ask Sophia not to answer the question directly in the chat, but to think about the answers and keep her answer for the discussion at the end. I think this is pretty much it. Any question or anything I'm missing before we get started? No? Are we ready to go? Okay, so our first presentation is about continuously managing NFRs, opportunity and challenges in practice. It's a journal first papers, and the presenter is going to be Colin Warner from the University of Victoria. Colin, whenever you're ready.
Sorry, Colin, I think you're muted.
Okay, let's try that again. Nothing like talking to yourself. But anyway, here we go. So continuously managing NFRs. What I'm going to present today is actually the practices and the challenges that we observed when we studied 3 organizations that are practicing continuous software engineering and how they manage their non-functional requirements. So I won't talk about the methodology or anything else. We'll just go right through the practices and challenges because that's what I find most interesting, and that's where we'll go from here. So our research unveiled 4 practices, and they were: put a number on the NFR, let someone else manage the NFR, write your own tool to check the NFR, put the NFR in source control. Just in case anybody here doesn't know what an NFR is, it's a non-functional requirement. So the first practice for dealing with NFRs is establishing metrics to help validate and assess a particular NFR. The concept of NFR metrics was frequently discussed throughout our interviews with the organizations. And we found that when an organization tracks pertinent metrics for NFRs, metric indicators collected by the organization's deployment pipeline provide valuable insight on NFRs. A critical success factor, putting a number on the NFR, is the feedback loop to enable the continuous monitoring of metrics. And the feedback loop, if you don't know, is an integral part of continuous software engineering and is one of the perceived benefits of adopting continuous software engineering. Let someone else manage the NFR. This is probably the most popular approach that we found to managing NFRs. And it's essentially letting someone else doing it, manage it by offloading it, where that someone else is typically a large, cloud service provider such as Amazon Web Services or Google Cloud. Offloading an NFR means that an organization allows another platform or even tool to realize at least part of the NFR on the organization's behalf. Very rarely would you offload the entire NFR, but you can offload the large brunt of it. An organization's ability to focus on core functionalities of their software is heightened by offloading the brunt of the work to realize, NFRs that aren't as important to their software, such as scalability, reliability, availability, et cetera, the ones that you usually consider with, Google Cloud platforms, et cetera. However, we found that offloading an NFR is not as simple as flipping a switch to realizing an NFR, because in some cases, or many cases, there's some form of configuration required. So the third practice was write your own tool to check the NFR, as opposed to offloading the NFR to a third-party service or tool. We found that organizations also wrote custom in-house source code or tooling or scripts or manifests, et cetera, et cetera. However, for a resource-constrained organization, a custom tool is probably the last resort that they want to do, where either the existing off-the-shelf solution or open source, did not sufficiently meet the particular requirements at hand. The last practice we found was put the NFR in source control. So we found that, at the organizations, the workforce was constantly changing, usually growing, and the products were experiencing a rapid pace of change. And this constant change required that developers gain a clear understanding of the NFRs of the product so they know how their changes might impact these NFRs. And so this concept of codification refers to using code and related artifacts such as version control configuration files to capture NFR knowledge. So there's the 4 practices. Now we'll go over the 3 challenges. So not all NFRs are easy to automate. There are many different kinds of NFRs out there, too many to list, and there's no silver bullet used to automate all of them or any of them in particular. Some NFRs are more difficult than others, but adopting CSE approaches to development, which means committing and deploying at an extremely rapid rate, appear to make this an even greater problem. So the second thing we found was that they're growing very rapidly, and so employees have to balance other responsibilities, and there's limited resources. So we found that NFRs are an easy target to bump from the sprint plan or milestone due to a lack of clarity or even around how to value or verify or define an NFR. And then the last is a shared understanding of an NFR implies that everyone with an NFR is in agreement with the meaning of that NFR and its various components. And this shared understanding relies on knowledge transfer from the people, such as a product manager or even a CEO, whoever created the NFR, to those who might affect it. So we found that shared understanding is a challenge for these subject organizations. They face problems with inconsistency in what gets explicitly stored in source control, with tacit knowledge and a low circus factor, and problems with role siloing. So that's it for me.
Very good. Thank you. Okay, so we're going to move to our second talk. It is called Evaluating the Impact of Falsely Detecting Performance Bug Inducing Changes in Just-in-Time Models. And it's another Journal First papers, and it will be presented by Sophia Quash from Concordia University.
Hi. Can you see my screen?
Yes, we can.
Okay. So my name's Sophia, and I'm presenting my work. These are my collaborators. I worked on this during my master's at Concordia. So SEZ is very popular, and it's been discussed and used in many papers. And in an ideal scenario, it's used to identify the exact changes that introduce a bug. And in our ideal case, in our paper, we consider the results to be changes that are identified by the SEZ approach that are truly bug-inducing commits, or known as true positives. So to know whether or not a change introduces a defect, just-in-time defect prediction uses the SEZ approach, which links each defect fix to the source code change introducing the original defect. It does this by combining information from the version archive to the bug tracking system. And our paper focuses on studying just-in-time performance-related bug-inducing changes and how they impact the performance of JIT models, as well as on the data itself that's produced by the SEZ approach, which are the bug-inducing changes that are detected by SEZ. So in our prior work, we find that SEZ has low accuracy for non-functional bugs. So a question we ask ourselves in this paper is if the extremely low accuracy on SEZ on performance bugs would impact just-in-time defect prediction. So we ask ourselves 3 research questions. The first one is, how well can just-in-time models predict performance bug-inducing commits? So similar to Kame et al., we consider 13 factors that are grouped into 4 dimensions. These are to categorize the data. So we build random forest models as our JIT classification models. And because of the imbalance of bug-inducing and non-bug-inducing commits in our data, we find that it's suitable to use random forest trees to not overfit the models on non-bug-inducing commits. We also explore other alternative models that may be used, and you can find these in the paper. So at first, although you see that the AUC scores for performance bug-inducing commits is very high, and much more than bug-inducing commits, the ground truth is wrong because we hadn't verified the data yet to make sure it was actually bug-inducing. And these are the values for random forest. You can find the values of the other models in the paper. So we make an extra step where we verify and fix the wrong results from the SEZ approach. So for research question 2, because of the results of research question 1, we can see that the wrong result, wrong slide. So from research questions 1 results, we can see that the wrong results of SEZ did make a big impact on the model. And so in RQ2, we want to see if one can correct such results from SEZ and whether the model can perform better. So here we used the manually verified data in the model training. And then we find that the AUC score is increased after we correct the wrong results from SEZ and use the correctly labeled results to build the model. And the AUC values are in a good range. However, it's much lower than for non-bug inducing commits. And so in RQ3, we think maybe the nature of the model of performance bugs and other bugs is so different that it makes no sense to put them into one model. And that might explain why there's different accuracy in predictions. So we're thinking that maybe we can build a separate model, but only for performance bugs. So we build a variety of models. But we find that including all the data still appears to be the optimal solution for now, which is shown in model perf and non-perf, where the training data is comprised of X-1 performance bug-inducing commits, non-performance bug-inducing commits, as well as non-bug-inducing commits. And you can find the details of the other models also in the paper. So that's my work. Thank you for your time, and I'll be happy to answer any questions.
Thank you. Okay, so let's move to a third paper. It's called Issues in the Adoption of the Scale Agile Framework. It's a paper from the Software Engineering in Practice track, and it's going to be presented by Artem Kruglov from the Unipolis University.
Hi, Cecile. I believe Artem is still having troubles hearing and seeing people, so I was wondering if he could present last.
Sure, absolutely. Let's move on to our next paper. So another paper on quality. So it's going to be how to debug inclusivity bugs, a debugging process with information architecture. It's a paper from our Software Engineering in Society track, and it will be presented by Maria Guzzani from Oregon State University.
Right, I'll go ahead and share my screen.
Yes, we can see it.
Hopefully you can see it now.
Yes, we
Perfect.
can.
All right. So my name is Mariam Guzzani. I'm a PhD student at Oregon State University, and I'll be presenting how to debug inclusivity bugs, a debugging process with information architecture. So diverse teams have been shown to be more productive as well as more innovative. And one form of diversity is what we call cognitive diversity, and this helps generate diversity of thoughts. However, cognitive diversity is not often supported in software tools. And some software tools are not inclusive of individuals with different cognitive styles. For example, people who like to learn through process versus people who like to learn through tinkering. And this could create what we call a cognitive tax. So following on commits that could introduce bugs in codes, we're going to talk here about inclusivity bugs. So what are these? So these are biases in software that could introduce inequities. And these might be showstoppers, but they don't have to be. They just introduce another cognitive load on the person using the software or going through a process or going through a project or using a certain use case. Let's take an example to picture this better. Sarah is a comprehensive learner. She does not like to tinker, and she has little spare time. She's doing her capstone project, and she finds an open source project that she can reuse for some features. She gets really excited about it, and she tries to set up her environment. However, she gets confused and lost setting up the environment and finding the right information. She tries again and again, but feels like she's wasting time and ends up abandoning the project. It turns out, unfortunately, that all the information that she needed was actually there. But it was so fragmented and disorganized that it made it impossible for her to find and use. And this is one example where an open source project, which is here the scope of her study, hinders comprehensive and process-oriented users. So let's talk about GenderMag, which is one of the methods we use in this study. So GenderMag is a specialized cognitive walkthrough that has 3 personas, Abby, Pat, and Tim. Abby and Tim are at the opposite end of the spectrums, and it has 5 facets. So we'll dive into one of the facets just to give an example, which is the learning style. So for example, an Abby-like persona learns best through process-oriented learning, example processes and algorithms, not just individual features. However, a Tim-like persona learns better by tinkering and sometimes would backtrack whenever they find that they're not going about the use case that they want to go to, or they get distracted. Now, what are we proposing? So the systematic inclusivity debugging process we call WhyWe're-Fix is as follows. So we have the why part, which is about finding inclusivity failures, which is analogous to testing. But because this is not tied to wrong output, we need to discern exactly why the observed phenomenon is considered as inclusivity failure. And this is where the GenderMag method comes in. Then we have the where, which is a way to tie the inclusivity failure to the faults. And this is analogous to fault localization. And for this, we use information architecture, which is the way information is structured, organized, labeled, etc. And then we bring in the whys and the where to help systematically figure out a fix. Our method was twofold. So we had a field study where an OSS team took their project, their original open source project, applied the WhyWe're-Fix, found 6 inclusivity bugs, and fixed them and generated the diversity enhanced project. We then took these 2 projects and ran a lab study with students as participants to evaluate how students used both of them and how this impacted the cognitive styles of learning, the different cognitive styles of learning. So I'll dive right into the results. So this table shows that in the lab study, the original versus diversity enhanced project, so the total number of bugs encountered in the original project was 20 versus 2 for the diversity enhanced project. So here we see that the WhyWe're-Fix reduced the number of inclusivity bugs by 90%. But you might ask, what about inclusion? And here we could look at a different table where when we compared the effects on the Abby-like facets at the top in orange and the Tim-like facets at the bottom, the effects of the fixes were all positive, showing that the IA fixes increased inclusivity on the prototype across all cognitive styles. And if you recall, these fixes were actually made for Abby, but they ended up helping both Abby and Tim, which is another important thing when fixing inclusivity bugs. So here we can see that the IA fixes have made the project more inclusive. Now, another question to ask, what about equity? Does this help with equity? And a basic definition of equity is the quality of being fair and impartial. So let's take two of the bugs found in the original project. So bug 1 and 2 has affected 5 of Tim's facets and 14 of Abby's facets. And we can see here that there's a big inequity in the original project. Now, after the fixes, the project Diversity Enhanced project has affected 0 of Tim's facets and 2 of Abby's facets. And we can see that the difference has decreased here. So actually the IA fixes made the project more equitable. And also, if we notice, even Tim's facets were reduced as well, even though the fixes were actually targeted towards Abby's facets. So now as a conclusion, we proposed the why, where, fix process. And we found that the IA fixes using this process reduced the number of inclusivity bugs the participants experienced by 90%. And one thing to point out is that using this process does not support one population at the expense of another, but instead it produces a positive effect across all the diverse cognitive styles. And here I like to think about the curb cuts and how they're made for somebody who might be disabled, versus when you're also using a carry-on, or maybe somebody with a stroller could also use this in a more situational aspect. So thank you for listening.
Okay, thank you very much. So let's move on to next paper called Generating and Visualizing Tracelink Explanations. And it's a technical track paper, and it will be presented by Jinfeng Lin, from the University of Notre Dame.
Hi, everyone. My name is Jinfeng Lin, and I'm a PhD student from University of Notre Dame. Today, I'm glad to present our paper, Generating and Visualizing Tracelink Explanation. So software traceability is a technique to recover and mine the relationship between the software artifacts. However, manually generating these links is very expensive and time-consuming. So the researchers have already proposed many automated trace models to reduce the manual efforts and generate this link automatically. However, these generated links are not widely adopted in production. And from our perspective, there are two main root causes for this phenomenon. The first cause is that the generated links are not accurate enough. And the second one, and the most important one, is that this link lack of explanations. So given a group of the generated links, the rationales behind those links are not provided by the models. So our work, therefore, focused on providing the explanations for the automatically generated links between the software artifacts. So taking the following requirement and the design definitions for examples, the argument drive stamped message are closely related with the terms such as the curve velocities and angles, and the task plans often involve the movement planning. So people without such knowledges may have difficulty to understand why these two artifacts are actually related to each other. So in these studies, we identify the tracelink explanations from two aspects. The first aspect is the artifact explanations. So the explanation should help the readers to comprehend the artifact itself by explaining the domain vocabulary and the terminologies. The second one is that the link relation explanations. So the explanations should help the readers to understand why these two artifacts are related by connecting the terminology together. Our target users are the newcomer to projects and the stakeholders who trace widely across the artifacts using very different terminologies. So for this purpose, we propose 4 types of the explanation elements. For artifact semantics, we extract the acronym expansions, concept definitions, and the context usage. The acronym expansion maps the short format of the concept to its full name, And the concept definitions just provide the definition of the terminologies. And the content usage will provide the usage examples of the concepts by mining it from the corpus. And for the link semantics, we describe the relationship in a tupelet, which is composed by two noun as the subject and object, and we use a verb to describe their relationship. And our framework looks like this. So given the artifacts, we will first collect the sentences from the artifacts to create a project corpus. And then we apply a concept detection method to identify the non-concepts from the projects. And then in the step 2, we will elect the domain-specific concepts by using a general concept blacklist created from the UMBC corpus, which is a very general corpus, including the web page and the actor. So after we collect these domain-specific concepts, we will use this concept as the search queries to construct our domain corpus. And we propose two different methods. In the top-down approach, we'll use this concept to retrieve the project-related corpus from a larger pre-collected corpus, such as the archive and the Wikipedias. And in the bottom-up approach, we just use the concept as the search terms and search it from the Google search engines and construct our project corpus, domain corpus from scratch. And then after collecting this domain-related corpus, we'll conduct the NLP analytics to extract the 4 types of the explanation element we have just mentioned. And then we're training quality control models in step 5 to help us remove the low-quality explanations. And at last, we'll present our explanation to users with a user interface. So our user interface actually looks in this ways. So this UI will integrate and display all 4 types of explanation element mined by our techniques. And user can use the mouse to click and interact with the components and to show the highlights and the explanations. So the explanation elements in UI are then evaluated in the user studies. We ask the users to vet the links with and without explanations. And we observe that the user's performance is significantly better when they are provided with the link explanations. And we also conduct the quantitative evaluations to the explanation elements. But for time considerations, we only show the evaluation for the definition and the context evaluation here. So in short, in both tables, we can see that the top-down approach extracts like way more elements than the bottom-up, because like the corpus is generally larger and broader. However, the bottom approach will provide the result with higher accuracy. And the main error made by the top-down approach is including the content from the out-of-domain corpus and introduce errors. So for wrap-up, our approach works best in the domain supported by a large corpus or public documents. And it can provide the complementary explanations in addition to the project glossaries, which is created by the humans. And the main bottleneck of our approach is that the sparsity of the explanation element in the corpus. So even though we collect a lot of the corpus, there is very small ratio of the content is helpful for the explanations. So thank you for listening and looking forward to your questions.
Okay, thank you so much. So now we're going to go to our last paper on SAFE, and the presenter cannot hear or see us, but we can. So Jordan, our student volunteer, is going to help him set up, and so he's going to present for us. So the name of the paper is Issues in the Adoption of a Scale Agile Framework. It's a paper from the Software Engineering in Practice track.
Okay, hello everyone. My name is Artem. Unfortunately, I can't see or hear anyone. So if you have any questions, please write in the chat and I will try to answer them. And now is my turn to start presentation. So one moment, please. Okay, let's start. Again, as I said, my name is Artem. I am presenting in Policy University here, and the paper I will talk about is issues in the adoption of the scaled agile framework. Before going to our research, brief recap of SAFE framework. What is it about? So, very briefly, it has this framework based on 4 core values, which are built-in quality, transparency, program execution, and alignment. Also, it defines 7 levels of core practices, which help to structure the work of the big company at a level of team. Firstly, then next level is the level of teams when the agile release trains forms. Then the level of solutions when several agile release trains work on the big software or cyber physical solution. And at the top of it, is the portfolio level where the overall strategy of the company discussed and aligned with its goals. So it's general recap, and now why we start our research actually, because through the literature we figure out that there are a lot of criticism, let's say, of SAFe framework, namely that SAFe is too complex and hard to understand, and moreover, some sources claim that SAFe, even not an agile framework, it leads to waterfall-like structure of the company and, in fact, inhibit agility instead of exposing it. And the idea of our research was to perform systemic assessment of same framework in terms whether it's agile at all or not. And we try to answer 3 research questions in our research. What are the most crucial success factors of SAFe? Whether SAFe hinder agility or not, and what are typical positive or negative effects of SAFe on large organizations. And the structure of our research were the following. It has 2 directions. The first one is the multi-vocal literature review. We analyzed about 200 resources, and from them we selected 19 papers, which represent white papers, means academic papers, and gray literature as well as blogs, posts, and etc., which were related to the discussion of SAFe framework. The second direction is a survey where we have conducted 25 interviews, mostly open-ended questionnaire with open-ended questionnaire, and summing up the results of these 2 directions of research, we perform systemic analysis by comparison the results of what we got. And now briefly the results of both multi-vocal review and the survey. They're the following. For review of the literature, we got the following success factors of SAFe. The most important ones are appropriate staffing, leadership support, and measuring change. Go into the idea whether SAFe hinder agility and how. We find that team structure, too detailed methodology, complexity, inability to improve, and requirements for alignment are those aspects which claim to in literature to be like aspects of hindering agility by the SAFe framework. And the positive effects of SAFe implementation are alignment, continuous improvement, and at the end, like on the top, is improved code quality. The negative effects after implementation of SAFe were a lot of upfront planning, difficulty and complexity of this framework, challenges for continuous improvement, and hierarchical decision making or hard alignment within the company. So after it, we have turned to the survey, and we interviewed again 25 persons all over the world from different companies, from different positions. And the results of this survey shows that the main success factors in SAFe, according to practitioners, is the leadership support, with much more votes than any other factor, according to the results. As for the second research question of the factors which hinder agility, we asked exactly the same aspects which we figure out during the literature review. We asked participants whether they agree or not with this factor, and as you can see, there we have some contradictions. So for too complex framework and not adaptability of the process, people have, well, more or less agreed with it, but for learning and improvement not supported and alignment is interpreted hierarchically, they mostly disagree with these facts. So we could say that these are not the factors that hinder agility when we implement SAFe. And the last results are positive effects and negative effects. Again, we approve what we found from our literature review, like better productivity, and the negative effect is requirement for resource. This is what we figured out. So to sum up, we could say that according to our research, we found that SAFE do requires an upfront commitment from all levels of organization to be successfully implemented. And the second point, rather than hindering agility, SAFE in fact exposes its essence, because being agile is not like a simple way of doing things. It's a waterfall style is a simple way, but when we try to become agile, well, the things become more complex, and it's not about hindering agility. Vice versa, SAFE helps to promote agility on each level of organization. And again, both from MLR and the survey, we got benefits as improved productivity and quality of product and processes. But SAFE do requires much more resources, external as money, additional staffing, and internal as well, as more commitment to the process and to organization as a whole. To sum up the research itself, I would say that it's somehow preliminary research of the things that we have performed, because not too many participants were involved in survey, and I do hope that this research will be the basis for further development and additional researches in this area. And moreover, I hope that we'll be able to perform the same research, the same systematic research for other frameworks which popular in industry, such as LESS, such as Scrum at Scale, Nexus, Discipline Agile Delivery, whatever else. And at this point, I would like to stop my presentation. Thank you for listening to me, and well, now I'm ready to answer your questions if you have any of them.
Okay, thank you so much.
I do hope that you hear that you hear me pretty well.
Yes.
Because again,
so Jordan, you're going to let him know.
I can't get any feedback from you
Yes.
because I can't hear or see anyone.
Okay.
Yep,
So
I'll
maybe
send him a message and make sure all questions go to the chat.
Okay, exactly. Thank you so much. So maybe we're going to now move on to our second section, which is about the interactive discussion. I would like to prioritize a question from the audience versus my question. I've seen a number of questions for Colleen.
Wow, okay. I see no questions in the chat, so probably there are no questions then. Thanks for your attention, and well, bye-bye, everyone.
Okay, thank you, Artem. So let's move on maybe with some question for Colleen. I see a few questions in the chat from him. So just unmute yourself and ask any question you might have for Colleen, since we have some question in the chat from both Jinfen and I think Marianne. So if one of you want to go ahead, go ahead.
Oh, I'm trying to find my question. Oh, yeah, I was wondering, Colin, if there were any NFR practices that were used in combination together?
Well, I guess it depends on your question is a bit ambiguous. Are you talking about like a single NFR that was used, that multiple practices were used, or did any organization use multiple practices? Pretty much every organization used multiple practices. And in many cases, particular NFRs were leveraging multiple practices. So for example, let's say you offloaded something to, like availability or scalability or something like that. So that's one practice, which is offloading. And then you might use another practice of putting a number on the NFR. So you might monitor, okay, how many instances do we have running? What's the CPU utilization, et cetera, et cetera. So even though they've offloaded the NFR, so they're not actually managing firing up these instances or not, but they're still actively monitoring or analyzing metrics to determine, if things are going right or if they're going wrong, or if they can turn things down, to fine tune these sorts of things. And there's also a terminology that is used is called ratcheting. So you can kind of ratchet an NFR up or down depending on, what the NFR is attempting to measure. So you could maybe turn some, lower the CPU usage or lower some of the RAM or et cetera, and see, whether it affects your NFRs.
Mm-hmm. And
Okay,
maybe
so
sorry.
go ahead, Marianne. Go ahead,
Maybe
continue.
to follow up on this, because this is really interesting, and I'm thinking about usability. If you've seen any cases of usability as a non-functional requirement and how they went about tackling that.
Yeah, so I mean, usability is one of the most common ones that we saw, and I'd say two of the organizations, usability was one of their primary concerns. If you actually go look at the paper, we actually counted the instances, or the frequency of the NFRs that occurred. So, and usability was one of the top ones for each of the organizations. One organization in particular that they, in order to manage their usability, they actually wrote libraries and kind of and a huge test framework on their actual UI system, which was a huge investment for them because they weren't actually using or actually writing any code. They were just writing this library. So that was one way that they did it in particular there. So I don't remember the exact details of exactly how they wrote the library, but yeah, usability is also one of the hardest ones to automate, and they managed to do it a lot with metrics. So they would follow exactly where somebody went through their application and basically record that, and then they could go back and analyze, okay, well, what's the most often used feature and how buried is it? And they would look at things like that. So there were lots of innovative ways that they did that, and a lot of them are actually described in the paper too.
That's really interesting. Thank you so much, Colin.
You're welcome.
Yeah. Jinfan, you want to continue on that?
Sure. Yeah, I think you answered part of my questions. So basically, I think the best practice is based on the user's need, and there's no best practice without considering the usage case. And my following question about the future. So do you think the future of the NFR management systems is what direction, how it will look like? It's like a giant integrated platform, or it's like very specialized small plugins, or like small softwares very dedicated for the user's needs on special cases? What's your opinion about the future?
Yeah, I mean, I can kind of talk about the future because this work was actually done a couple of years ago, and we've actually done some further studies on some of these concepts. And one of the studies that we did was actually on this concept of shared understanding of NFRs, and whether how continuous software engineering, does it help or hinder non-functional requirements? Because in software or continuous software engineering, everyone wants to get code out as soon as possible, and there's a huge, as I discussed, there's a huge focus on functional requirements, and they don't necessarily look at the non-functional requirements until either perhaps it's too late or that the system is completely unusable. So I think that's been a huge focus of this study, and those practices actually help manage the shared understanding because it brings visibility to the requirements, and it essentially gives them a definition of how they are managed, either through one of those practices or not. But what we also found is that there might be some hints that continuous software engineering actually hurts the shared understanding of non-functional requirements, again because of this focus on functional requirements and user stories and getting functionality out the door as soon as possible. So I think that's biased because that's where my research is going, and that's what I've basically written my entire PhD dissertation on, is this whole concept of shared understanding of non-functional requirements. So it's interesting to me, and that's sort of where I see the research or the community kind of leaning towards, is how do we increase the shared understanding of these non-functional requirements, i.e. give them visibility, and so that every engineer can understand them.
That's very good.
Well,
yeah, because okay, go ahead.
No, I'm just saying
Okay,
it's great answer.
yes. Yes, people don't really care. They're not really interested in, because we don't see the implementation until there is a problem, like the system crash or something like that. But until there is a problem, nobody is rewarded by implementing non-functional requirements correctly, right? So and it's hard because it's never ending. You're never done, right? So this is an interesting topic. I had a follow-up question. Could you maybe give us some example across the 3 organizations that you studied of some metrics that you saw collected throughout those organizations? And also, did you ask at all how they decide which metrics they are going to collect?
Yeah, so I mean, that's an interesting question. So I'll answer the last part first. So how do they decide which metrics to collect? I guess for every organization, every organization has a different set of NFRs. So how do they decide? They have to prioritize what their NFRs are. So one of the organizations, they were into selling ads. That was their primary, generation of revenue. And so, pretty much for them, one of their non-functional requirements was how effective is our software at selling ads. And so that's one of the, you could consider that a non-functional requirement. It was the only organization that had a requirement like that. And they built a huge amount of metrics to measure how much or how effective, certain parts or certain pages or certain aspects of their software was at selling some of these ads, or at least, generating revenue through ad sales. The other organizations, I mean, pretty much all the organizations looked at things like CPU usage, how many users are on the page. I mentioned earlier about how they track usability. So the organizations would do various things. One of the other organizations, they were a big data company. So they were really concerned about, processing data really quickly and as efficiently as possible. And then obviously storage, because they were processing massive amounts, terabytes and terabytes of data, every second. So they were more concerned about performance. So they would measure that, how much data are we actually processing per second? So it really depends on what the organization is and what's important to them. So I think that's where, you talked about not many people think about non-functional requirements, but an organization, at least these ones are relatively successful. And so we think the practices that they're doing are actually beneficial. And that's why we wrote this paper on it. So they're actually looking at NFRs, which is a good thing.
Yes.
And by creating these metrics, and most of them would actually put metrics up either on monitors in the office and stuff like that, back when, companies actually worked in offices. So that everyone had visibility of what was going on at the organization, and they could actually see and monitor these NFRs.
Very good. That's great. So yes.
What was the first part of your question? I forgot. Sorry.
Yes, that's fine. I think you did cover it. I think because of the time left, we might want to switch to a different paper. There is another, but thank you so much for this. And there is another question from the audience to Mariam, and it's a question from Sophia. Sophia, do you want to ask your question to Mariam?
So my question was if you could elaborate on information architecture.
Yeah. So information architecture is, you can think of it as like the way to structure information. So there are 4 different systems. So there's the organization system, which is, I kind of like to think about it as like building rooms, and it has like the scheme and the structure. So the scheme would be like, how do you group content? Do you group it by topic? Do you group it by task? And have a specific scheme that you follow the whole, like throughout the whole UI. And then the structure would be more like the relationship between the content groups, like how you create your hierarchy. And then there are systems like the navigation system, which is more like adding doors and windows to those building rooms. And that's where you want to have your either like contextual links, for example, or sitemaps, etc. And then there's the labeling system and how you go about labeling certain things, like how you go about labeling the links or headers, and kind of like adding door signs. And then there's a more of the like the search system, where you're giving a supplemental way to go about your content and information by providing some sort of a search system. So these are like the 4 known systems of the information architecture that we used. And then you can go a little bit like more granular where you're talking about specific elements in the UI.
Okay. Response.
Any other question for Mariam? I had a quick question. It's just by curiosity. It's a great research. I see a lot of application. I'm wondering if it's still something that academia is working on, or is it something that the industry already is concerned about?
Yeah, that's a really good question. Like, so the GenderMag method has been used in both like an academic setting and also in companies. And this is the why that we have. So this is how you find the bug. But then throughout, like when we go about fixing it, we wanted to add this additional IA element to make sure that there's a systematic way about fixing it. Because when you run these GenderMag sessions, there are particular people in the room. There are maybe the people that are working on the software or on the project, and they come up with all these bugs, but then they forget about them. How do they go about fixing them once they've already done that session? Maybe it's a week after. And following this process where you pinpoint exactly where that problem happened, just and kind of like go about it in a more systematic way. But yeah, it has been applied. And I saw your question also about academia.
Teaching. Yes.
And that's a really good one too. Like I think about this in terms of, you know, evaluating even just like we have Canvas at OSU, which is where you find all your assignments and like classes and everything. So that could be actually a great way of making sure these are like the way information is structured there, and that there's no inclusivity bugs there, because you're tailoring to a range of students, and they might go about finding information and processing information way differently. So you want to make their life easier. And this could be a good thing to apply. So this could be like taken on and applied on something like that.
Yeah, absolutely. Any other question for Mariam? So thank you so much. I think we should go maybe Jinfeng. Do we have question for Jinfeng from the audience? I have a question, but I will prefer to start with a question from the audience if we have one. Because my question is not exactly related to your research exactly, but more I'm curious about, I've been working with traceability myself since a long time ago, and I always felt some resistance, especially in the Agile community, because why would people want, for instance, to keep maintaining their requirements artifact while the features that are related to those requirements are already implemented? So what is your way of convincing people that there is benefits in doing that?
Yeah, I think currently the low adoption rate of the traceability is due to two reasons I have listed. One is the accuracy, and one is the explanation. And the most importantly is like the price for creating the links. And if you need like many people working many working days to just create links for a project, maybe the second day will change, then it's like totally worthless. However, I think currently at the deep learning technique approach, I think the automated model is more and more effective, and the accuracy is increasing dramatically. And that happened to be like my main research areas. So I have like, I can foresee the software traceability is more and more practical in the industry, and like one day will be used in the industry completely. And you can see like, even though the computation for the deep learning based traceability model is expensive, but like it's affordable when compared with the manual creating the links. And if, for example, if the trace link is free and is accurate, why the Agile community will refuse it, right? You can just click a button and you have the Agile connected, right?
Yeah, but my question was not about the link themselves, but if you want to link things, you have to maintain those things. And if those things are not valued by the community, then it's hard, even if though the links might be free, they might not want to maintain those requirements forever. So they create the links all the way to their test or something like that. So that was kind of a. So did you at all try to think about that aspect or not? I mean, you have plenty to do anyway, right? But that's an interesting question too. Any other question for?
So
yes.
Yeah, go ahead.
Okay. Yes. Any other question from Jin Fan from the audience?
Maybe what
I
like
think- Yes.
Oh.
Go ahead, Marianne.
maybe I was wondering what would be the next step? What would you see as a future to this research?
Yeah, so currently we actually hit the bottleneck. Like it's our first step of study. We want to demonstrate like two main ideas. The first idea that the explanation actually can help the users to understand the links. So this is proved by our user studies. And like we do the A/B test, and the user actually can work better with explanations. And the second is that we want to prove that this explanation can be automatically generated. So it can be work with the automated model, trace models. And the future is that we want to make this explanation more versatile and more accurate. And the bottleneck we raise right now is the sparsities. So I think the next step we want to address is that how can we find the explanation from very limited resources. And currently we just use the information retrievers. And I think the generation-based deep learning models maybe can help us in these areas.
Thank you.
Okay, thank you so much. Maybe we need to go to Sophia. And Sophia, because we have an audience from different software engineering discipline, maybe you can tell us what is SZZ, because I'm sure some of us have no idea, including me, what is SZZ.
Yeah.
That will help us better understand the entire research.
So I took a diagram from my paper. So here it shows a bug fix and the corresponding identified bug-inducing change from SEZ. So SEZ attempts to find a source change code changes that first introduces a software bug, and it does that by identifying the change that introduces the bugs, starting from the bug fix change. So we have to know the ground truth of where the bug fix is, and then for each identified bug fixing change, the SEZ approach will analyze the lines of code that were updated to introduce the fix. And it does that by tracing through the versioning history of the source code management system. So Git, for example.
Okay, that helped. Thank you so much. So we have only a few minutes left. So what I'd like to do now is to go through all of presenters and ask the question, if there is one thing you want us to remember from that presentation, what will that be? And you have like 30 seconds to answer that question. And we'll start with you, Colin, if you don't mind.
Sure. So I guess the one thing that I'd want you to remember is, that NFRs are important and that organizations are tracking them, and that there's a variety of practices that can be used to manage your NFRs. But of course, there's caveats and there's challenges associated with them. So, that's pretty much it.
Okay, thank you. Sophia, you're next.
Okay, can you repeat the question? I didn't understand.
If there is one thing you want us to remember from your paper that you can summarize in 30 seconds, what will that be?
I guess for now, including all bug-inducing changes and non-bug-inducing changes of all types will be best for predicting future bugs.
Very good, thank you. So let's move on to Mariam.
One thing to remember, I'd say, is that you want to tackle inclusivity bugs in your software, in your open source project, or even in your academic software. And there are ways to do it to just make your software more inclusive. And it's just going to make it easier for people with different cognitive styles to adopt your software or to use it. And you want to lower the barrier. So, yeah.
Very good, thank you. And so, Jin Fan, you are the last one.
Yeah, so in brief, the automatically generated link explanations can help the users to understand the trace link patterns. But to actually generate in production, we still need to tackle the data sparsity issues in this area.
Okay, thank you so much, everyone. So I think we are at the end of our hours. Thank you very, very much to the presenters for great presentation. Thank you to the audience. And I wish you a great rest of ICSI. Take care, everyone. Bye-bye.
Thank you.
Thank you.
Mhm.